In this exercise, we're going to demonstrate a practical use for the stack data structure, and that's for converting numbers from one base to another base. In this example, we're going to demonstrate how to convert from base 10 to base 2 to binary values. So the first thing we did is took the stack and before the program converted it a little bit by having it store integers instead of strings. So that each time we push a value onto the stack, it's going to be an integer because we need to store zeros and ones since we're converting to base 2. So we made the data store array, an integer array. We push integer values onto the stack. We pop integer values off the stack. We peek at integer values at the top of the stack. And then finally, when we clear the stack, we set each default data store value to a 0 rather than the empty string when we were using strings. So now we're ready to write our function to convert base 10 to base 2. So we'll call it convert, and it will take a number. We'll create a constant, call it base, and set it to the value 2. Next thing we do is we create a stack to store our binary digits. We'll call it digits. Then we write a do while loop and we say do digits push number mod base. And then we say number is equal to number divided by base while number is not equal to 0. So this is the algorithm for actually converting a number in base 10 to a base 2 binary string. Then we can say while digits.count is greater than 0, cout digits pop. And that will display our binary number after we've converted it. So the main algorithm is right here, where we take a number mod base, in this case base 2, push that result onto the stack, and then divide number by base, store it back in number to do the next conversion. And we do that while the value of number is not equal to 0. So now we can write some code to test our function. Prompt the user to enter a number, retrieve it, and then we can say cout number base 10 equals, and then call the function with the number, and then cout, put a space there, base 2, and del. Build and run the program and try it with the value. Where you can see it. Let's try 2. And so 2 base 10 equals 1, 0 base 2. That's right. Let's try it with another number. Let's try it with 4. 4 base 10 equals 1, 0, 0 base 2. That 2 is right. Let's try one more simple result. It's because we can only keep track of so many binary numbers. 5 is 1, 0, 1. So there's a practical use for a stack, converting base 10 numbers into base 2. There are lots of other things you can do with stacks, but I just thought this would be a simple enough exercise to demonstrate and convince you of the practicality of using stacks when the problem arises. And that wraps up this exercise, and now we're ready to move on to the next exercise where we work with queues.